Hello ladies and gentlemen, welcome to our lesson today. Today we're going to be talking about function multiplication and division. So in our last video we talked about function addition and subtraction. We did a little intro on what function operations are. So function operations, if you don't want to go back and watch the other video, are basically any type of mathematical operation, so like addition, subtraction, multiplication, and division, that you do using functions instead of like normal numbers. So just a real quick example of a mathematical operation, like 3 plus 2 is a mathematical operation, okay? And so a function operation is just, instead of using our numbers like we do here, we're gonna use functions. So we'll just get right into it. Basically, everything you need to know about function operations is we talked about in the last video. This one we're just gonna be multiplying and dividing functions instead of adding and subtracting them. So here we go. So for the first one, and the way that you'll be asked to, the way that you'll be asked to do these problems is going to be very similar to our addition and subtraction problems. So sometimes all that the book will ask you to do, or all that your homework or worksheet or or whatever, all that you'll be asked to do is to find g of x times, little dot there for the times f of x, or f of x times g of x. Remember, multiplication, doesn't matter what order we do it in. And so similar to with our addition, we just take what we know to be g of x right here, and we'll substitute that in. We'll have x, and then we take to what we know f of x to be, plug that in, so we have x times x, which in this case would be x squared. Wow, bad too. All right, which would be x squared. So this one, as you can see, pretty simple. Also, if they asked you to find, so let's say they asked you to find, instead of just g of x times h of x, if they asked you to find, I'm going to flip them this time so that we're on the correct side with each one. If they asked you to find g of 2, or wow, excuse me, can't talk. If they asked you to find f of 2 times g of 2, then we're going to just find our general formula, which we said was f of x times g of x, which we just said was x squared, right? And then we can plug in a 2 to that x squared, which would just be 4. And if you'll remember from our function addition and subtraction video, there are two ways to do all of these operations. The first one is like this, where we find the general form, and then we plug in whatever we're finding our number for. Or we could, if we wanted to, do it the other way, where we plug in our 2's first, okay? So we say that f of 2 is equal to 2, and g of 2 is equal to 2. And then so f of 2 times g of 2 is equal to 2 times 2, which is 4 still. So a couple different ways you can do these ones. Yeah, not too bad. So do a little bit of a harder example now. And you guys will find that, sorry if I'm looking down here, it's my notes. You guys will find that a lot of these problems are similar to the type of work that we did last semester with foiling and multiplying polynomials. This is going to be a very similar exercise, only now, instead of just giving you the polynomials that we need to multiply together, squish together, we're going to ask you to do some work beforehand. So let's say in this problem, if they asked you to find f of x times g of x, we're going to take our f of x, 2x plus 1. I put it in parentheses because all of this is f of x, okay? And then we're going to multiply it by our g of x, which is just 3. So the way that we would do this now to find the general form, we'll shoot our arrows or distribute or whatever you want to call it, it's all the same. And so we'll have 6x plus 3 as our final answer. So this would be the general form. All right, so now let's say they asked you to find f of 3 times g of 3. Well, we already have our general form here, so we can just plug in a 3, which would be 18 times 3. Or 18 times 3, 18 plus 3, excuse me, which would be 21. Or if we wanted to, instead of starting with this general form, we can plug 3 in to both of these and find that first. So we can say, oh, and our answer was 21, I believe, just so that we remember. So f of 3 is equal to 2 times 3 plus 1, which is 6 plus 1, which is 7, right? All those are equal. And then g of 3, well, what do we do with this one? Okay, so when like we said in the last video, whatever's here, we're substituting in for all of our x's. Well, there's no x's here, so g of 3 is just 3. G of anything is 3 because no matter what we substitute our x for, well, there's no x. So our g of 3 will be 3, our g of 2 will be 3. Anyway, this will just be 3. So now our our f of 3 times g of 3, which is what we were finding, I erased it, oops. So our f of 3 times g of 3 is now equal to 7 times 3, which is 21, which matches with our original answer that we got when we did it the other way. So there you go. I obviously work, just a real quick note, I obviously work a lot faster in the videos than I do in class. I do that because on the YouTube, you guys can, you can pause, you can rewind, you can see it again. Obviously in class I try and go a little slower so that you guys can catch it the first time around. But if you need to rewatch any of these examples, please do so. Obviously the internet is a powerful thing, so take advantage. Yeah, so we'll just keep on moving with some more examples. So now we're gonna do x squared plus 2x minus 5, and we'll have 8x plus 2, minus 2. All right, and then this is our little separator. Sorry, they got a little smushed. So this is our f of x, this is our g of x. So the general form of this, f of x times g of x, we'll just do what we've been doing. We'll put our f of x down here. We'll go x squared plus 2x minus 5. And I'll put that in parentheses again because this is all f of x, and we're saying that all of f of x times all of g of x. And then our g of x is 8x minus 2. And on the last problem, I didn't put g of x into parentheses because it was only one term. But if there is more than one term that we're working with, I would suggest putting it in parentheses. Yeah, so now we just need to shoot a bunch of arrows. Okay, so we'll go like this, like that. So I'll talk through it, but I'm just gonna kind of go kind of fast. So we'll have 8x cubed minus 2x squared, and I'm thinking I might be running out of room over here, so I'm just gonna kind of go, and then I might do this on 2 lines, which might be confusing, but we'll see. And then we'll do plus 16x squared minus 4x. And so, sorry, I know this is confusing. This is gonna be, I'm gonna go down to this line, but it's gonna be part of this same thing here. So we're gonna have minus 40x plus 10. So this is all, I guess I should have checked how much room I had side to side, but this is all what we get when we foil this together, or super foil, whatever you want to call it, right? Because we go our first term times both of these terms, that's what this is. We do our second term times both of these terms, that's what these two are. And then we do our last term times both of these terms, which is what these are. So now I'm going to come back down to the center and combine like terms. So I have 8x cubed, and then so that takes care of my x cubed term. I like to cross them out as I go just so I don't forget. So now I'm going to look for all of my x squared terms. I have a negative 2x and a positive 16x squared, which will leave me with a 14x squared. Done with those guys now. I'm going to look for my x terms. I have a minus 4 or a negative 4 and a negative 40, so negative 44x, and then plus 10. So there's that one, and then like I said, we can cross these off. So I know that I got all my terms that were here into this now. So this would be f of x times g of x. This would be the general form before we plug anything in. And so this one's kind of a doozy. We could plug some stuff in if we really wanted to. But I'll just, I know you guys would probably throw it in your calculators, and there's nothing wrong with that, but yeah, I'll just leave this one as it is. So this is the general form. You might be asked to find something like this where it was like f of 2 times g of 2, right? And then you'd plug a 2 into all this and you'd get some big crazy number. So yeah, we'll just keep on moving though. Sweet. So now we're gonna move into some, so that was all multiplication that we just did there. And obviously, right, we were multiplying, so multiplication. So now we're gonna do some, division, work on that. So problems like this, function division, we're gonna be asked to find what f of x divided by g of x is, and not always f of x divided by g of x. It could be g of x divided by f of x. It could be, if there's an h of x over here that we had equal to 1 or something, right? It could be any of those. But we'll have two functions that we're being asked to divide into each other. So this one, similar to all of our other operations, we're just looking for what f of x is here to put in our numerator, which is just x. And then we're looking for our g of x to put in the denominator, which is 3. So for this one, we just have x over 3. That's all we got to do. If you were asked to find f of, I'm really stuck on these 2's today, but we'll keep rolling with the 2's. So if I were asked to find f of 2 over g of 2, we could throw a 2 into here and be done, because we already found our general form. Or we could, if we wanted, find what f of 2, find what f of 2 is equal to, right? Because we just plug a 2 in for all of our x's, and then we could find what g of 2 is, which is just going to be 3. It's just going to hang out. It's like kind of like that other example we did. So then we would just plug those in here, and we'd get 2 over 3, which was the same as we got just a second ago. So there's that one. Now, in the domain and range video, I talked about domain and range, I talked about some graphs, I talked about finding domain and range. One thing that I did not talk about was domain restrictions. So if you guys will remember, domain is the input, or it's our x-axis when we think about graphs. And so I'm going to give you guys a function division here that has a domain restriction, which I will explain a little more in depth here in a second. So we're going to go f of x equal to x plus 2 and g of x equal to x. So if we were asked to find f of x divided by g of x, we would get x plus 2 over x. Hopefully you guys can see that. Again, we're looking for f of x to put into our numerator, x plus 2, put that into our numerator, and then we'll look to put g of x in our denominator, which is just an x. So, domain. The one example I gave you guys in the last video was just a linear function, right? It was just a function that was a line, and it went forever. Its domain was negative infinity to infinity. Its range was negative infinity to infinity. If you don't recall that, or this is kind of confusing, you can hop back and watch that, or ask me about it another time. Either way, fine with me. So that function's domain, that linear function, was negative infinity to infinity. The domain of that function was. So now, this problem has a domain restriction. What that means is that it's not going to have a domain of negative infinity to infinity. It's called a domain restriction because this function's domain, okay, it's, as we go along the x-axis, is restricted, right? And so if you're restricted from doing something, that means you're not allowed to do it, you can't do it, etc., right? So this problem has a domain restriction. And the domain restriction comes from our denominator, okay? So the one problem with this denominator is when it's equal to 0, because we can't divide by 0. I think in one of the other videos I told you guys to ask Siri what 0 divided by 0 is. It's just not good, right? So whenever our denominator is equal to 0, we can't plug in a value. So we need to find for what value of x our denominator is equal to 0. So for this one, it's pretty easy because our denominator is x. For our denominator to equal 0, x needs to equal 0, all right? And so what we would say is for this problem, its domain is equal to, and if you guys remember the fancy notation, all real numbers not equal to 0. So this is saying all real numbers, which is every number, right? And then not equal to the number 0, because when x is equal to 0, our denominator is 0, and that's gross, we don't like that. So if you guys were asked to find, okay, bear with me here. If you guys were asked to find f of 0 over g of 0, we can't do that. The reason we can't do that is because we'd have to plug a 0 into here, which would give us 2 over 0. Sorry, I know I'm getting kind of squished, okay? So if we're finding f of 0 divided by g of 0, we would get 2 divided by 0, which is bad. We can't do that. So if you are ever asked to find a problem, or to find the value of a function division that gives you a 0 on the denominator, what we're going to do for our answer is we're going to say it is undefined. And you can abbreviate it with UND. So for this example, if you were asked to find f of 0 divided by g of 0, you would end up with an undefined. But, okay, so I'm going to rewrite this here. So our f of x divided by g of x is x plus 2 divided by x. Say we were asked to find, instead of f of 0 divided by g of 0, if we were asked to find f of 1 over g of 1, we can do that because we're going to plug in a 1. We're going to plug in a 1 for all of our x's, so we'll have 1 plus 2 divided by 1, which is just 3 over 1, which is just 3. So for any number that we're given, except for 0, or our domain restriction, we can do this and get out an answer. But if you're asked to find the value of a function division where the denominator is equal to 0, we can't do that. We're going to put undefined. Okay, and I have another example with that. So if that's a little shaky, that's okay. Okay, because we haven't talked about that necessarily yet. Maybe we sneak it in somewhere. Not exactly sure how the next couple days will play out, but here we go. So next example, we're gonna do. And again, I'll put this little dotted line here so we can know that they're separated. X minus 3. So if we were asked to find f of x divided by g of x again, we're just going to substitute in our f of x and our g of x. Okay, so there's our f of x. Now we're dividing by g of x, which is going to be x minus 3. Okay, so for this problem, whenever there's an x on the bottom, we know that there's going to be some kind of domain restriction. Because if we just had a 3 on the bottom, 3 is never equal to 0. Right? We know that. Numbers just don't work that way. So 3 would never be equal to 0, so we wouldn't have to worry about it. But when we have an x, which can be any number, we have to think about domain restrictions. So for this one, our domain restriction, or the value of x that would make our denominator 0, okay, I'm going to try and say this a lot of different ways not to confuse you, but hopefully so that one of them sticks, right? Okay, so the value of x that makes our denominator 0 is going to be 3 here. And if you're not sure how I came up with 3, you can do a quick x minus 3, set it equal to 0, right? Because we don't want it to be this, so we want to know what value of x makes this 0, so we can just do a little plus 3 on each side. X equals to 3, okay? I did that in my head, okay? But if you guys need to do this, totally fine, okay? So our value of x that makes the denominator 0 is 3, so that means that our domain of this problem would be all reals, that's all reals, okay? All reals not equal to 3, all right? And so again, for this problem, if you were asked to find f of 3 divided by g of 3, similar to the last one when we had 0, when you plug these in, you'll get a 0 on the bottom, which means that we're at a domain restriction and that our answer is undefined. I don't even need to know what this top is. Like, I could plug this 3 in here and I'd get 9 plus 6, 15, minus 5 is 10. I'd get 10, but it doesn't even matter because I know that the bottom I'm going to get 0. Once you see that your denominator is 0, your answer is undefined. That's just, you don't have to do any more work. That's that. So, there you go. But, okay, so now if we were asked to find, instead of f of 3 and g of 3, if we were doing f of -1, g of -1, I know how you guys feel about negative numbers. It'll be all right, I promise. I'm going to leave this here. I won't leave it there. That's our domain restriction, but it's not relevant to this, so I'm going to erase it because I have kind of limited space that I'm working with. But so if we were asked to find f of -1 and g of -1, we would plug it into this general function here. So I'd have -1 squared plus 2 times -1 minus 5 all over -1 minus 3. So this would be, so a negative times a negative is a positive. So this would be equal to 1 minus 2, because positive times a negative is a negative. So -1 times positive 2 is -2, minus 5. That 5 is just hanging out, nothing going on there. And then on the bottom, we have a -1 minus 3, which is a -4. And then we'll combine these. We have -1, -6, -6, and then this -4 stays on the bottom. And hopefully you guys remember, when we have a negative on the top and bottom of a division problem, we can cancel them and make them both pluses. Okay, so we end up with an answer of positive 6/4. There you go. And so all 3 examples that I've shown so far of function division, you found the general form, and then we've plugged in numbers. The reason I tend to do that on division as opposed to other ones is because of that domain restriction. Because I might not be able to just look at these and know what my domain restriction is, but when I put it into that form where they're already combined, I can see the domain restriction. But if you're feeling lucky and you feel like maybe you can do this and there was not a domain restriction, you can. So say again, we were asked to find f of -1, g of -1. You can do this the same, or we can do this the other way, which is similar to how we've done all of our other ones so far. You can find f of -1 first and go and say that that's equal to -1 squared plus 2 times -1 minus 5, which we actually just did a second ago, was -6. Okay, so we can find f of -1 first. We can plug that -1 in there first. And then we can find g of -1, which we said was -4. And then we can just throw those on either side of a fraction, on top and on bottom, because that's what we have here. And then again, they both become plus, which gives us a positive 6/4. So you can do it the other way, but sometimes you run into a domain restriction. And even if you do it this way, if you do it this way, right? If you do it this way, you might run into a domain restriction, and you'll know when your denominator is 0. That means that we're at a domain restriction. Didn't mean to throw my eraser. So there you go. So these are all the examples I have for you guys today. Hopefully by the time we get to this lesson and you watch this video, we've talked about domain restrictions, but if not, that's why I talked about it a little today. I'll talk about it in this lesson if we haven't. Yeah, so there you go. There was 3 examples that we did of function multiplication, 3 examples of function division. The next lesson we're going to be talking about function composition, which is kind of like we're taking all of our function operations that we've learned so far, so addition, subtraction, multiplication, division. We're taking all of those and we're kind of squishing them together a little bit, and it'll make more sense when you guys see it. But yeah, so there you go. Hope you guys have a wonderful day. I'll see you in class tomorrow. Yeah, and if you have any questions on this stuff, don't be afraid to ask me in class when we're working on homework, or even, before class, maybe before we get going on lecture stuff. Whatever works. So just let me know, guys. Have a great day, and I will see you soon. Bye.